Good evening. Let's take a look at some basic sketching of quadratic functions. We are given the function of f of x is equal to x squared plus 8x plus 15. We notice that this is a positive quadratic, so if I wanted to sketch this quadratic, it will be concave upwards, therefore there will be a minimum point for my graph. They say clearly show all intercepts and the turning point, in other words the minimum, or the vertex of this quadratic. So if I want to start this, I will first start by finding the y-intercept. So the y-intercept is relatively easy. The function is in the form ax squared plus bx plus c. So my c value is my y-intercept. In this case, it is 15. If I want to find my x-intercept, then I have to make y 0. So my x-intercept, y is equal to 0, therefore 0 is equal to x squared plus 8x plus 15. Then I can factorize this. In other words, I can create two sets of brackets. So if I look at the factors of 15, I notice that 5 and 3 added together will give me 8. So it factors well. Then I can use my guide number rule. So not the guide number rule, I'm going to use the null factor law. In other words, I can say x plus 5 is equal to 0 or x plus 3 is equal to 0. Therefore, x can be equal to negative 5 or x can be equal to negative 3. These are my x-intercepts. In other words, I solved for x. I found two definite x values. Another word that they can use here is they can ask us to find the roots of my quadratic function. So I have my y-intercept and I have the two roots. Next, I want to find the turning point. So the turning point, I've got two alternative methods to do this. The first is I can use my vertex formula. So to find the x-coordinate of my vertex, I'm going to say x is equal to negative b over 2 times a. In this case, what is my b value? My b value is the coefficient in front of x to the power of 1. In this case, it is 8. So it is positive 8, so I'm going to say negative b, negative 8, divided by 2 times of a. The a value is the coefficient in front of x squared. In this case, this is a 1. So I'm going to say 2 times 1 is 2. Therefore, negative 8 divided by 2 is negative 4. This is the x value of my vertex. I still have to find the y value of my vertex. What I will do is I will plug in this negative 4 into my function. I can say y is equal to, or alternatively I can say f of minus 4. I can plug in this negative 4 into my equation. So then I'm going to say negative 4 squared plus 8 multiplied with negative 4 plus 15. So negative 4 squared becomes positive 16. And now minus 8 times 4 is minus 32 plus 15. And if I simplify this, I will arrive at minus 1. So my vertex, if I use my vertex formula of negative b over 2a, will be minus 4 and minus 1. Alternatively, I can complete the square. So f of x, I can say f of x or y is equal to, fine, is equal to x squared plus 8x plus 15. But if I am going to try to find the perfect square for this, it is going to be difficult. So completing the square, I'm going to say the following. I'm going to take my b value, I'm going to write it up here. So I'm going to say b divided by 2 squared if I want to complete the square. So the value of b in this case is 8. 8 divided by 2 gives me 4, squared gives me 16. So I'm going to say x squared plus 8x plus 16. But now, if I want to add a 16, I cannot change my equation, so it should be able to cancel out. So I'm going to say plus 16 minus 16 plus 15. The plus 15 stays the same. Remember, this plus 16 and minus 16 is equal to 0. So actually, they do not have an immediate effect here on my function. I'm going to use this because what I want to do is I want to be able to say x squared plus 8x plus 16 can be factorized as x plus 4 squared. Now I have a perfect square. Minus 16 plus 15 gives me minus 1. Now if I have my function here, y or f of x, is equal to x plus 4 squared minus 1, we say that this is in vertex form. Remember, for inside the brackets, actually this is supposed to be a negative, therefore I notice that my x value for my vertex is minus 4, which we see is the same value that I got here on the left hand side. And my y coordinate of my vertex is still minus 1. So my vertex from my vertex form is minus 4 and minus 1. Then, if I want to go and sketch this, so I will go to the next page. Let's make another page here. And I am going to sketch this. So let's make a rough sketch, just to show how it would look or what I would do. So of course this is not going to be according to scale. This is just a rough sketch. So I'm going to have my x-axis and my y-axis. Now, our turning points. We have found that the roots, or the roots or the intercepts are minus 5 and minus 3. So here, on the left-hand side, I'm going to have negative 3 and negative 5. That is going to be my intercept points for the x value, negative 3 and negative 5. My y-intercept was 15, so this will be high up here. My graph will definitely not be according to scale. So 0 and negative and 15, that's my y-intercept. And I have my two x-intercepts and then my turning point. My turning point I have calculated to be minus 4, minus 1. So x is minus 4. It's right between minus 3 and minus 5. And my y value will be here, minus 1. So minus 4, minus 1. And then if I wanted to go and sketch my quadratic function, I can connect the dots and I can indicate that it comes onwards. So here is my quadratic function. Of course, this is not very accurate. I'm trying to draw it freehand, but you can try to make a neater sketch than this. And of course, I have indicated the intercept points and the turning point.